Okay, so we're going to talk about a nested for loop. And so this basically just means putting one for loop inside of another for loop. And there's a few different cases where this is useful, the main one being creating like a grid design. So we'll look at how to set that up. Nested basically just means one thing is inside of another. You can think of it like a bird's nest. A bird's nest kind of contains the bird eggs. So that's the term we use for when one thing is inside of another. And this is something that we see basically everywhere when we're doing website development or digital media projects. You can see it in our code, when we have a function or an if statement that's inside of another if statement or another function. And you can kind of open or close these little guys. That shows that part of your code is nested in another part of your code. With a nested for loop, we basically have two loops together. This shows an example. So this is going step by step. Normally, obviously, we just do the whole thing at once, but we're going to do this one showing this step by step. So each time I click the loop button, we see the result of one part of our loop. So you can see that there's one for loop, which starts with x equals 0 on the first line. And then inside that loop, there's another for loop, which starts with y. And the thing that makes this very powerful is that our y loop is going to run a full series for each one series of our x loop. And so that makes it possible to create a whole grid with just a few lines of code. So then you can see the only actual drawing code that we have in here is on line 3, where for each step of our loop, we're drawing an ellipse using x and y. We're using x plus 50 and y plus 50 to kind of shift the ellipse over a little bit, but that's all the drawing we're doing. So the first time we draw our circle, x is 0 and y is 0. So that's how we get that circle in the top left corner. Now if I click loop, now x has stayed the same. Okay, so we're in the interior, the y loop. So in the y loop, every time we go through the loop, y is incremented. So we get y plus equals 100. So our first guy started x equals 0, y equals 0, and we draw our circle. And then we're still in this loop. So we go back to here, and we run through our steps again. So y is still less than height. And so we add 100 to y. And that's how we get this circle. X is still 0, y is 100. So we're still inside the interior y loop. So let's do that a couple more times. So we go through the loop again. 100 is still less than height, so we're going to run our code again. So we draw our third circle. X is still 0 because we haven't looped on x. We're still looping through y. So we add 100 to y. We get 200, and then we go through it again. So we loop back. X is still 0. Y is now 300. And so we draw our circle at x 0 and y 300. Then we go back to the beginning. And now what we'll see is that y is no longer less than height. And so we finish our y loop, but then we're going to go back to the x loop. And then we start the y loop again.
I'm having trouble. I don't understand why x doesn't move.
So x starts at 0. So we start by defining x as 0. And then this is our first loop. So as long as x is less than width, we're going to add x 100 to x. So this is our first loop. Then we go into our y loop. So all of this code, everything that is in the y loop is going to run before we go back to our increment x. So we set y is equal to 0. As long as y is less than height, we add 100 to y. So we draw a circle, and then we get to the end of our y loop. So we go back to the beginning of the y loop. We don't go back to the beginning of the x loop because we haven't finished the y loop. So we go back to the beginning of the y loop. Y is 0, so y is still less than height. So we add 100 to y. So now we haven't done anything to x, but we've incremented y to 100. Does that make sense?
Yeah, is it because the for let y is under the for let x, so it overrides the one above it?
It doesn't override it, but this is like, so imagine, this is like if we wrote, and it is under, but what's significant is that it is contained within. Okay, so let me do an example. Okay. So if I have 4 let x equals 0. Maybe I haven't used let before, but let is just the same thing as var. It's just a little bit, it's more modern, and it works a little bit better, but it doesn't really matter. Let and var are the same thing. Okay, so if I say let x equals 0, x is less than, let's say, for this example, I'll just use 10, x plus plus. Okay, so if I do this loop, I'm just going to console.log x and then the value of x. So we just count up 0 to 9. When we get to 9, 9 is less than 10, so we stop. So in here, if I do another loop, if I say for let y equals 0, y, and let's use a smaller number, so I'll just use 4. Y is less than 4, y plus plus. And I console.log y. So there's the difference here is that in this example, I'm only drawing inside the y loop, but here I'm doing x and then I'm doing y. So notice what happens. X is 0, and then I'm printing y 0, 1, 2, 3. And then we go back to x is 1. So everything that happens in the x block happens each time we loop through x. So this is sort of like, if I didn't have a for loop here, this would be like if I just logged y 0, console.log y 1, and then just keep going. Okay, so if I did it this way, I would get the same result. So I start with x equals 0, and then I go through y0, y1, y2, y3, and then we go back, and now x is 1. The difference is, since I can, these statements are almost the exact same thing, I can, instead of repeating this code, I can write another for loop that does it for me. So what's significant is that this is inside here. Yeah. So if it was down here, if I moved all this down here, then what would happen is I do all of my x's first, x0, x1, x2, x3, and then I do all my y's. Since now when I move these y's down here, this whole x for loop happens before I ever get to here. But if they're inside here, if I put them back in here, and maybe I'll change these to z's. Everything that happens in here happens each time I go through the loop. So now with this version, I have x0, and then y0, 1, 2, 3, x1, then y0, 1, 2, 3, x2, y0, 1, 2, 3, x3, y0, 1, 2, 3, and then we're done with our loop, and we go to z.
So it will overwrite as long as it's nested, right? Like as long as the second statement or whatever is nested,
Yeah.
it will like overwrite the first one.
It's not overwriting it, it's just
Yeah,
happening.
It
Yeah.
prioritizes the one that's in the brackets.
It's not prioritizing it either. It's just the progress. It's just like the progression of statements. So I could write this whole thing. I could say console.log x and say it's 1. And then I could do that. Let's say I just wanted to count to 4. And so I could say x, 1, 2, 3, 4. So that's just the series of commands, and it's in the order that I asked it to be in, right? So if I want to do this command, instead of repeating console.log over and over again, I can do a loop. A loop is an easier way to repeat something 4 times. So I just have to format that loop. So I can say for let x equals 1. As long as x is less than 5, we're going to count to 4, x plus plus. Now I can console.log x. Okay, so I get the same result, but I'm using a for loop to do each step one at a time. But once I'm inside this for loop, anything else I do in here is also going to happen each time I do the for loop. So if I just say console.log hello, each time I print x, I'm also going to print hello. And I am going to do that every time I go through. So then where this becomes tricky is if I put a loop inside of a loop, I have to go through the whole loop before I get to the next part of the loop. Yeah. Yeah. So if I put another loop in here, so if I put another loop in here, this whole loop has to happen before we go back to check if we should keep going with x. So each time we do x, we're going to say this is x, we're going to say hello, and then we're going to do our whole while loop. And so we're going to repeat our whole while loop. So we do x, we say hello, we do our whole while loop, and then we go to the next x loop. So it's a little tricky, but it's not, it's basically just taking a lot of lines of code and finding ways to consolidate them into smaller expressions. I want to repeat something this many times, or, you know, I want to draw each part of our grid this many times. Okay, let's go back. So we're back to, we've done our first while loop, and when I click loop again, now x is back, it goes to 100, y goes back to 0. So what happened is we drew this guy down here, y was 300, so we go and we look here and we say, okay, we're going back to the beginning of our while loop. Y is not less than height anymore, so that means we're done with this loop, but we're still inside of the x loop. So then we go back to the x and we say, okay, x is 0, 0 is less than width, so let's increment x and let's do the whole thing again. So now x is 100, y, now we do this loop again, so now there's a new y, and that new y is equal to 0. So this is a completely new loop with a completely new variable. It looks like 2 lines of code, but if we actually wrote out every step that the program does, it's creating a completely new y variable when it goes through the second version of the loop. So now we do the y again. Y is 100, y is 200, y is 300. Then we start over again. We increment x by 100. We create a brand new y loop. We go through, and then eventually we get to the end. X is 300, y is 300, and both loops end, and that's it. That's our grid.
And the height, of course, that varies upon each project. So every time,
yeah.
It's like, so I guess your height in that what it is, 300 or 400?
It must be. It looks like it should be 400, which means that it should be. There should be more after that, but it must be like 399 or something.
All right,
okay. Oh, this one is a little broken. Shoot, I forgot this. I need to fix this. So we'll just do that. We'll just do that in the example. Okay, so let's write our own for loop. And we're going to look at a couple different ways to work with this. And so we're going to kind of retouch on the whole X and Y versus transformation thing. So we'll see, I'll show you guys a couple different ways to do this. And there isn't really a right way to do this, but depending on maybe how your brain likes to think about things or maybe what your approach is going to be, you may find one better than the other. So let's set up a P5 sketch. So this is our nested for loop example. And it's April 1st, April Fool's Day. Okay, so we're gonna have a function. We're just gonna set up our canvas. So we'll say create canvas, do 400 by 400. And then I'm gonna make a pattern function. So I'm just gonna call the pattern function. So again, with this one, we want to avoid the draw loop for now, because if we use the draw loop and once we start to add in random and things like that, it's gonna get really, really crazy. So we want to avoid that. So we're just gonna make a pattern function instead of a draw function. So because the pattern function is one that we made up, we have to call it ourselves. So in our pattern function, let's draw our gray background, and then let's add our loop. Okay, so for our loop, we'll do basically the same thing. We're gonna say for, I'll just use var because that's what we've been using most of the semester. For variable x, x is less than width, x plus equals 50. We'll draw an ellipse at x, and for now, I'll just do 50 on y, and we'll do 50 in the size. And so if we just do one for loop, we've done this a bunch of times already, we'll see that, you know, we get a series of circles. They don't exactly cover our grid area or our canvas area, but we can make a couple of adjustments. So since the circle is 50 pixels wide, if we want to move it over, we can add 25 pixels. And if we want the Y to be lined up, we can do 25 pixels there. We could also, you know, just make it go farther. So another way I could do that is I could say X is less than or equal to width, and then we'll cover the whole canvas, but we'll overlap on the edges. So again, it kind of depends on what you're going for, but you can do different versions of this. So let's put Y at 0 for now. And so now we've got kind of the top row. And so if we want to add in our nested for loop, we basically, you know, a lot of the time you can just copy and paste the loop and just switch the Y's around to X's. But we can also write it in. So we're just going to go to the next line, say for variable Y equals 0, Y is less than or equal to width. And then I'm going to use the same values here, 50, but you don't have to. You could use different values for your X and Y. And then I'm just going to move my ellipse in here. And I forgot to put in the Y, so I still just have 0. So now I put in the Y, and I get my full grid. Usually we go X and then Y, but you don't have to. You could do it the other way around. You could start with Y, and then for each row, you could do a row of circles going across all the columns. So usually we do X and then Y because we usually say X and then Y. That's usually the order we use, but it doesn't have to go that way. So then I'm going to show you guys a couple different ways that we can make patterns. So I'm going to do a couple things in here, but then I'm going to do another loop and show another example. And you'll see that it looks, you know, we can do more or less the same thing, but the way we think about it is going to change a little bit. Okay, so let's draw some faces.
And the third part of your loop condition, it's plus equal means that it's gonna start at 50 and it's gonna add 50.
Well, it starts at 0.
Okay.
So x equals 0 is where it starts, because we're assigning 0 to x.
And as long as it's equal or less than width,
Yeah,
it's gonna add 50.
exactly.
Okay. And why are you putting the equal there?
This plus equals?
Yeah.
This is the same thing as saying x equals x plus 50.
I remember you explained it before.
Yeah. So it's just a shorthand. It just makes it easier to read, basically. So it's basically the difference between adding 50 versus adding 50 to the original value. Okay. So if I want to draw a little face, let's turn off the stroke for a second. So I've got some circles. So if I want to draw a little face, a self-portrait, so I'm going to have the head. And so I'm going to have to draw some eyes and a mouth. So let's change the color. Or let's make a fill for the head first. I'll do purple. Okay. So I've got some purple circles. And then let's do some blue eyes. So when I'm using x and y, remember that I have to set all my values relative to x and y. Okay, so if I say ellipse at 50, 50, and I'll do 20. So that blue circle, let's make it a different color because it's hard to see. I'll do light blue. Okay, so we see that circle, but it's only in the first circle. It's only in the first column and row. That's because I'm not doing relative to x and y. I'm just writing in numbers. So if I say x plus 50, that breaks something. Not sure why. Oh, I know what's happening. It's getting covered up because I went too far. Let's do x plus 20. Let's do x plus 10. Okay. So now you can see I've got it in that one row, but I don't have it in the full thing. So I've offset this by x, but not by y. So when I'm using x and y, everything has to be relative to x and y. Otherwise, it's just hard-coded. It's just in the same place every time. Okay, so if I make this y, let's do y minus 10. Now I've got my first eyeball. Let's make it a little bit smaller. Okay, so now, every time I draw that circle, even though I'm only drawing it once, this is the left eye. Even though I'm only drawing it once, by using it relative to x and relative to y, as I go through my loop, remember I'm going to hit each one of those points. I'm going to hit each one of the circles as I go through. So as I loop through, each one of my eyes is x plus 10 or y minus 10. So it's going to be 0 plus 10, 0 minus 10. Then it's going to be 0 plus 10, 100 minus 10. Then 0 plus 10, 200 minus 10. So the x and y update as I go through the loop. And so my eyes will be in the same place each time as I go through. Okay, so if I want to do a right eye, I'll copy this. And I'll just go the other direction. So I'll say x minus 10. Okay, and then let's do our mouth at the bottom. So I'll do a rectangle. I'll probably do x so it's in the middle. And maybe y plus 10, so we go down a little bit. And then I'll probably do 10 for the height and 5 for the, or actually no, let's do 5 for the height, 10 for the width. And let's do a little rounded corner. Oh, wrong way. I had it right the first time. 10 for the height, 5 for the width. Little rounded corner. And then it's kind of in the middle. Where did I mess that up? Oh, the rectangle draws from the left. So I actually want to do like x minus 5, whatever the size is. So maybe we want to do like 20 actually. Okay. So now we've got our little pattern. And now any adjustment that I make to the face, of course, is going to be adjusted to every part of the pattern. If I want to offset one of the eyes a little bit more to make it look a little bit different, any tiny adjustment I make, it affects every part of the pattern because I'm just repeating that same code over and over again. So again, everything has to be relative to x and y. The advantage of this is that if I change the values of x and y or change the number of elements in the grid or do different things like that, other things will adjust according to that x and y. The disadvantage, of course, is that I have to use x and y every time I make a new shape. So I'm going to show you guys another method that is similar approach, basically the same idea, but using transformations instead of using our x and y variables. Well, we actually have to use the x and y still, but we'll use transformations as well. Okay, any questions? Okay, so now we can create cool patterns. So I'm going to make another pattern. I'm going to use the exact same for loop, so I'm just going to copy this. But this time, I'm going to use transformations. So I'm going to say using transformation. Okay. And I'm going to, for a minute, I'm just going to hide the face. So I'm just going to comment out my face. Okay. So inside this for loop, if I say, let's draw something other than a face. What should we draw? We can draw, let's just draw a triangle. Actually, triangle is a good one because triangle is hard to do with x's and y's, right? So let's draw a triangle. So I'm going to draw a triangle. I'm going to put it from 0, 0 to, let's say, 50x and 25y. And then, so that'll be our second point. And then our third point will be 25y and 50, or 25x and 50y. Let's see what that looks like. So we get this nice little triangle. Let's give it a bolder fill color so it'll be easier to see. Okay, so let's make it green. Okay, so our triangle is inside of this big for loop, but we only see one. So even though we know, because we understand how the for loop works, that actually, you know, we've done this drawing however many times this is, dozens of times, we only see one triangle because this is hard-coded. It's not relative to x and y. So we could go in and say x plus 0, y plus 0. Okay, so that's just one point, so it doesn't really work, but we can see that we're starting to move our points around x and y. Or the other thing we can do, if we don't feel like using x and y, is we can just translate our entire canvas to this xy. Okay, so we can say translate xy. So now we're moving the triangle. You can see there's a problem though. Remember that translations are additive. So we start to translate, but then we're getting farther and farther away because we're adding translations on top of each other. So you might remember we can do push, we can translate, we can draw our triangle, and then we can do pop. Now we've got our triangles. So in this case, I don't have to use x and y while I'm drawing because I've translated the entire canvas to each one of these xy points. So now I can just use my, hard-coded numbers, but I've translated to each point along the way, and so I can draw my triangle at each one of those points. So again, neither one of these ways of drawing is better. It's just two different ways of doing it. I think for some people this is easier because they can just translate and then they can just use numbers. So if I want to move the triangle around, I don't have to think x plus blah, blah, blah. I can just say if I want to move, one side down a little bit, I can just change that to 40, see how that looks, and then keep going. For some people, this is preferable because they're used to using X and Y and they want to, think about it in that way. Also with this one, if I hard code all of this stuff and then later I decide to change, X to 100, now my design doesn't necessarily shift to match what I've done. Although the way I wrote the previous example wouldn't shift either. So it just kind of depends. Yeah. Yeah. So let's review that real quick. So if I'm drawing in my sketch and I say translate to 200, 200, and I draw a circle at 0, 0. So I've translated to 200, 200. So that's the middle of my canvas. So the origin of my grid or my, canvas is now in the middle. So if I draw an ellipse at 0, 0, my ellipse is in the middle. Now, if I want to draw another ellipse somewhere else, if I translate again, let's say I translate to, let's say we stay on X and we move farther down on Y. And I draw another ellipse. So now this translation is the adding of this first translation plus this translation. So that's kind of tricky because I have to remember I already translated 200, 200, and then I translated again 0, 100. So if I want to do each one of my translations separately, what I can do is push and pop. When I push and pop, what I'm doing it's doing some stuff in the back end of P5 that we don't really see. But basically what it's doing is it's saying like our normal, canvas with 0, 0 at the top left and everything else, scale is 1, etc., is like our first transformation. And when we push, we're adding a new layer. And then any changes we make are on that layer. And then we pop, we take that layer off and we go back to where we started. And so you can add as many layers on as you want to. So if I push the first translation, if I push before that, and then pop here, now it goes back to the original translation, which is 0, 0s in the top left. And so now this translation is just going from 0, 0. And so by using push and pop, I can basically reset my transform to the default so that I can move it across the page without having to do like some confusing math. Especially here, if we wanted to do this without push and pop, what we'd have to do is we'd want to translate by X and Y each time, but you can see the first time we do it, it's just 0, 0. Then we translate to here. This is 50, 0, but then it skips. And it skips because we're adding this 50 translation plus this new 100 translation. So this should really be here, but it skips one because we're adding them together. This one is even farther down because we keep adding to that number. So to undo that, we'd have to do some crazy math, like subtract X times the number of translations we've done. It might not actually be that bad. It might just be like, let's see if, no, let's not worry about it because I don't think it'll be challenging to get it right. Anyway, so that's why we push and pop. That just allows us to save the previous translation and then pop back to that translation. So each time I'm translating from the top corner rather than the previous place that I translated to. And then I can, draw other stuff in here. If I want to draw a circle next to my triangle, I don't care about X and Y anymore. I can basically just ignore that and use hard-coded numbers. So if I want a circle that's kind of like in the top left, I could say circle is maybe like 25 and 10 and 20, something like that. Okay, so I got a little circle and I can move it over, can move it down a little bit. I can start to design just basically each cell of my pattern or each, part of my pattern just using hard-coded numbers.
Will you explain looping because I'm not understanding what right and I think it's because of the looping.
Yeah.
I'm making it a little bit confused.
Okay, yeah, let's do another one. Okay, so let's do okay, I'm just gonna write the current translation. So if I write the text 0 at 0, 0. Okay, so normally when we work in P5, I'll make the text a little bit bigger. Normally when we work in P5, 0x, 0y is the top left corner. And that we know that because when I draw a circle, if I draw an ellipse at 100, 100, 100, we go in by 100 pixels, we go down by 100 pixels, and then we draw our circle. When I translate, I actually move that position. So if I translate to 200, 200, 0, 0 is now it's in the middle of the canvas. Because I translated from 200, from 0 to 200. So I moved the whole center of the canvas down into the middle.
Like the axis, right?
Yeah. What we're really doing actually is just changing, like, if we think of our canvas as like a camera looking at this like digital space, what we're really doing is we're moving that camera to a different point. Usually the camera starts and the top left is here, but if we want, we can move it over here. And that's useful because it makes it easier to center things. If I want a circle that's right in the center, I can put it at 0, 0. I don't have to calculate, you know, what the center is. I know that the center is 0, 0. So you don't have to do these translations. It just makes it easier to do certain types of math. So if I translate more than once, it's gonna add together. So if I translate again and then just do the same thing, let's flip my text down here. So if I do this whole thing again, see how now my circle is down here? So I started 200, 200, but then this is the same translation, but because I had already translated, I translate again further down the page. So that's confusing because if I want to keep translating to move around like I do in my loop, then I just keep adding to the translation. And so to do this, I would need to say like 200, minus the original to get, if I really just wanted to go to the same place, but I needed to translate again, or I just needed to translate like 1 over, I need to go back to the original. So I could do that. I could like translate negative 200, negative 200. And now I have two things that are in the same place. But instead of doing that, I can undo this original translation if I save it in a separate layer. So I have my original translation with 0, 0 at the top left. When I push, this is just a simple way of saying push a new layer onto the main transformation. Now, when I translate that layer, I'm leaving the original the same place. Okay, so then when I pop that new layer, so I take that new layer off, I'm going back to the original, and so now my new translate will go wherever I want it to. The reason that's useful for the loop, let's imagine we're doing this in the loop. And so let's say my first translation is like 100x and 0y. And I'm just like going across. So then my next one would be 200x and 0y. So I'm just going across the page. But at a certain point, I can keep going, but then I'm going to have to do a new one, and I'm going to have to go back to x. But if I just push and pop, that way I can translate to exactly where I want to go without worrying about what my last translation was. So if I don't push and pop here, if I take that out, now I translate 100, but then I translate 200 from that 100. Versus when I push and pop, I'm always translating from 0, 0. And that applies to, you know, rotation and scaling as well, but in this case we're using translate to create our grid. Okay. Okay, so I'm going to stop here. I'll put this, you know, there's this is in the class collection, so you guys can take a look at this. You can, you know, make a template. You can duplicate the template, and then you can modify it, add your own drawing code in it. I'm going to go over another way of setting this up later in class and talk about using randomness to create some, you know, generative choices in our pattern. But for now, just play around with the nested for loop and see if you can make a pattern that you like, that, you know, repeats in rows and columns.